All right, let's talk about the Model Context Protocol, or MCP for short. This is a really big deal because it's aiming to solve one of the gnarliest headaches in AI development right now. How do you actually connect your models to the real world? So, if you're building with AI, you're going to want to stick around for this.
So, here's what we're going to cover. First, we'll look at the big integration problem that started all this. Then, we'll dive into how MCP actually works. After that, we'll talk security, which is a core principle here. We'll also check out the ecosystem that's building up around it and wrap up with a key question. When should you actually use MCP?
Okay, Section 1, the AI integration problem. You know, to really get why MCP even exists, we first have to talk about this hidden complexity that's, frankly, holding AI back.
So why are current AI tool integrations so incredibly complex and, let's be honest, so brittle? I mean, if you're a developer, you've definitely felt this pain. You know what I'm talking about? That feeling when you're trying to connect an LLM to a simple database or an API, and it just breaks. Well, the root cause is something we call the N by M problem, and it's a real mess. Think about it. For every N AI models out there, you have to build a totally custom integration for every M tools you want to use. This just creates an absolute explosion of one-off, expensive, and fragile code. It's a total nightmare to maintain.
Okay, so that integration chaos, that's exactly what MCP is here to fix. Let's dig into how this standardized protocol actually works.
So, what is MCP? At its heart, it's an open source standard for connecting AI applications to, well, to everything else. And honestly, the best way to think about it is this. It's like USB-C for AI. Seriously, it's one standard plug, one protocol to connect anything you want. Data, tools, you name it.
And the architecture? It's actually surprisingly simple. It's a classic host-client-server model. I love this restaurant analogy they use. The host is the restaurant itself, the building. The client is the waiter, running back and forth. And the server, that's the kitchen, where all the tools are and where the real work gets done.
This separation is really the key to the whole thing. So the host, that's your main AI application. Think a chatbot or maybe an IDE. The client is just a little connector piece that lives inside the host, and its only job is to talk to a server. And the server is a lightweight program that exposes all the good stuff, the data and tools, to the host.
So, how do they all talk to each other? Well, the communication is really well defined. All the messages are in a format called JSON-RPC 2.0, and the connections are stateful, meaning they stay open. For local stuff, running on the same machine, it's super simple. It just uses standard I/O. For remote connections, it uses HTTP and server-sent events, which is cool because it lets the server push updates back to your app. An MCP server can provide three main things. First, you've got resources. This is just the context and data the AI needs, like, say, the files in a folder or some entries from a database. Second, you have tools. These are actual functions the AI can ask to run, things like create a calendar invite. And finally, there are prompts, which are basically pre-made templates or workflows to help users get started. Okay, so this is all incredibly powerful, right? Giving AI access to tools and data, which means we absolutely have to talk about security. And with MCP, security isn't some add-on, it's baked in from the very beginning. It's all about building trustworthy agentic AI.
And you don't have to take my word for it. This quote from the spec itself really says it all. The Model Context Protocol enables powerful capabilities through arbitrary data access and code execution paths. With this power comes important security and trust considerations that all implementers must carefully address. Basically, they're saying, this is powerful stuff, so you have to be careful.
And the protocol is super clear about the rules. There are three core principles that are totally non-negotiable. First, and most important, the user must explicitly consent to everything, no exceptions. Second, data privacy is paramount. Hosts can't just send your data anywhere without permission. And third, before any tool is run, the host must get your explicit consent. Again, so what does that actually look like for a user? It's simple. It's a clear UI prompt. Before an AI can, say, create an event on your Google Calendar, you'll see a pop-up asking for explicit permission. It's all about no hidden actions, no surprises. You, the user, are always in control.
All right, so the protocol is powerful, it's secure, but is anyone actually using it? Let's talk about the ecosystem because it's growing fast. And then we'll do a quick start to show you just how easy it is to build with it. Yeah, MCP is definitely not just a theoretical thing. It's getting real traction. It was originated by Anthropic, now you're seeing OpenAI's agent connectors using it,
You've got integrations like LangGraph and adapters, and big players like Figma and Single Store are already implementing it. The ecosystem is really starting to take off. And you know what? We can actually build a server in like 60 seconds. I'm not kidding. Check this out. Step 1, you run a single command to install a pre-built server. Step 2, the client, like the Claude desktop app, just automatically discovers it. That's it. Step 3 is just using it. You can start talking to it in natural language to call its tools. It's that fast.
And boom, a successful tool call. Just like that, the MCP server has connected to the database, grabbed the information, and sent it back to the AI host. That right there is the plug-and-play magic of having a real standard.
Okay, so now that we know what it is and how it works, let's get to the really important part, making the right architectural choice. When should you actually use MCP?
Look, it really comes down to a trade-off. If you're just doing a simple, single-purpose integration, yeah, a direct SDK or API call might be faster to get going. But if you're building a real, extensible AI system that needs to connect to lots of different tools, now and in the future, MCP is a no-brainer. The benefit is that it's standardized, pluggable, and discoverable, which is exactly what you want for an ecosystem. And the architectural benefits are huge. Let's break them down. First, pluggability. This means you can add brand new capabilities just by installing a new server. You don't have to touch your main application's code. Then there's discoverability, where your app can dynamically figure out what a server can do at runtime. And my favorite, composability. This means an MCP server can also be a client to another server. You can literally chain them together to create some incredibly powerful workflows.
So all this leaves us with a really big question, doesn't it? Is a standardized protocol the key to unlocking true, professional agentic AI? I mean, we're moving beyond simple chatbots now. The real goal is AI that can actually do things reliably and securely. And maybe, just maybe, a standard like MCP is the key piece of the puzzle we've been missing.
Hey, if this was interesting and you want to go deeper, definitely subscribe. Because coming up next, we're going to go way beyond that 60-second install. We're going to build a full custom MCP server from scratch in under 10 minutes. You won't want to miss it.